Yes, class. Am I audible? Rabah, Rabia, Faiza. All right. Now, see, in the last class, we had started with series combination. So the equivalent resistance which we get once you have series combination is that directly added. R1 plus R2 plus R3 plus R4 directly keep on adding all the resistors. So this is your series combination. One question also we practiced in one thing in your series combination. To identify series combination, one important thing which we discussed was that current has to remain same. When we are discussing series combination, current has to remain same. If current is remaining same, means this is your series combination. If voltage remains same, then we have parallel connection. So these were the things which we discussed, and one question also we did. Now parallel combination is left from this, then we'll practice certain circuits. Now parallel combination means what? Current will divide. Why? Because here you will see branching is occurring. Now if branching is occurring, we have seen that branching doesn't affect your voltage. Potential doesn't change on branching. What changes? The quantity that changes is your electric current. Electric current changes as branching comes in the circuit. Now see, R1, R2, R3, all are different resistors. So current in each branch is different. Let's say n number of resistors are connected. N number of resistors are connected. So R1, R2, R3, R4 up till Rn. These many resistors we are having. So in each branch, individual currents will be I1, I2, I3, I4, I5 till Inth, right? Now, what is suppose the total current in the circuit is I. So what are the individual currents? This is I1 plus I2 plus I3, I4, I5, I6 till Nth. Nth current, nth amount of current we'll have, right? So here you can see at one side you had completely one single current. And on the second hand, the second resistor had one single current. But when we are talking about all the currents together, we are getting their combination. So I is equal to I1 plus I2 plus I3, I4, In. Now you apply your Ohm's law. What did we study in Ohm's law? You have V is equal to IR, right? So V is equal to, if we have V is equal to IR, from here, I will be equal to V by R. So this becomes V by R equivalent. Now, will the potential change for the first resistor? No. Potential will still be V. So, V by R1 plus V by R2. Up till you have V by R in it. So, all the potentials get cancelled. What are we left with? 1 by R equivalent. So, see, this is equal to 1 by R1 plus 1 by R2. Keep on adding all the resistors reciprocally. If you add all the resistors reciprocally, you get the equivalent resistance combination, parallel combination. Now see, when we had seen the series combination in capacitors, we got the same formula. Remember, in series combination of capacitors, we had the same thing. 1 by C1 is equal to, 1 by C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by C3. So similarly, parallel combination of resistors is similar to series combination of capacitors, whereas series combination of resistors is similar to parallel combination of resistors. So remember one formula and make the other as opposite. Try to remember this. Capacitors you have already studied, that you will remember by yourself. Similarly, see, if I ask you what is the total voltage, you will tell me V is the total voltage. If I ask you individual voltage, you will tell me V is only the individual voltages of all the circuits, right? This only you will mention. If I ask you individual currents, suppose if I ask you individual currents of each resistor, now how will you answer? So individual current, see, I1 will be equal to V by R1. I2 will be equal to V by R2. Potential will remain the same. Resistors will keep on differing. Now, nth, for any value of I, take the potential divided by the number of resistor you have. This is how you will get the individual current, because this time individual current will not be same. You will have different values of individual currents. Nextly, Coming to power. See, one formula I square R we discussed in the series section. Remember I square R. Why did we use that formula I square R? Because in I square R, your current is remaining same. So you are completely having the knowledge. When we are saying I square R, you are completely having the knowledge of current, right? So that's why we are applying it. Now here in this case, we are having different value of current. So we will not use I square R, because for individual resistors you can even use, but if we try to calculate and find it out for the separate resistors, then how will you calculate? So for that particular purpose, we are using this formula, that is V square by R. Similarly, P2 will become V square by R2. So you will have the individual resistors powers like this, right? So P1 is equal to V square by R1, V square by R2, up till like this. So power nth will be V square divided by nth value of resistor, like this. Nth value of resistor you will have it. Now we'll practice one question from this, then we'll do other types of questions. These are just the basics question which we have to discuss. Note down this. I'll give you the question, try it yourself first and I'll discuss it. All of you had received the link, no, of this class, or wasn't it shared today? You all received the link, no?
Yes, ma'am.
Okay, okay.
Done, ma'am. Ma'am, what is P?
Yes,
What is P? What does P means?
power, power.
Power.
P is power, V is potential, and R is resistance. Yes, answer of first question. By now, you people must have calculated it. In the chat column, I didn't receive any answers. This is similar to the series question which we had done. Values are exactly the same, 5 ohm and 10 ohm. Any answers by anyone? R equivalent. What is your R equivalent coming? Yes, see, 1 by R equivalent here. No, 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 Rabba, that is series. They are in parallel. See, when wiring occurs, no, when wiring occurs, like this branching occurs in your circuit, then your single straight wire gets divided into two components, right? Not 12 by 10, 10 by 3. Yes, Shavis, 10 by 3 it should be, right? Because, see, 3 by 10 would be left to 10 by 3. Look at it, all of you, for the first part. 1 by R equivalent. This will be 1 by R1 plus 1 by R2. So that becomes 1 by 5 plus 1 by 10. Multiply this whole by 2 because your 1 by R equivalent, this the LCM, here this will be 50. Or you can take it as 10 also. Directly take it as 10, your answer will come. So that becomes 2 plus 1, which is 3 by 10. So this is my 1 by R equivalent. Class, this I have been telling a lot. Please reciprocate it. This is 1 by R equivalent. You have to find out R equivalent. So whenever you have to find out R equivalent, please write the complete value by reversing it. So 10 by 3. Second question is regarding current, no, total voltage. See, total voltage is mentioned in the circuit. You can directly see this is parallel combination. So voltage across each or total voltage. Very good, Rava. This would be 10 volt. So answer for the second part would be 10 volt. Third, total current. See, total voltage we have, total resistance we have. So can't we find out total current? V is equal to IR. So I will be equal to V by R. What is V? 10. What is R? 10 by 3. We have 3 ampere. So 3 ampere is the total current that will get divided between 5 ohm resistor and 10 ohm resistor. Right? Now, fourth part I think is voltage across each. Yes. Voltage across each. What should be the voltage across each?
10.
10. Very good, Raba. See, voltages do not change in your parallel combination. So if this is 10 volt, this will also have 10 voltage. This will also have 10 voltage. The quantity that will change is your current. Current won't be 3 amperes in both the branches. So voltage portion is very easy for voltages. V1 is equal to V2 is equal to V, which is 10. Now current across each, I have told you first current will be voltage divided by first resistor. So this becomes voltage is 10, 1 is 5, so that becomes 2 ampere. And I2 will be V by R2, that is 10 by 10, which is 1 ampere. You can check also, 2 amperes plus 1 ampere is giving you the entire 3 amperes back. It means when in the circuit, this current will flow, current which is 3 amperes will flow. This will receive 2 amperes and this will receive 1 ampere. They'll meet again here, 2 amperes and 1 ampere, and again they'll get combined and go as 3 amperes back. This is how your branching occurs in parallel combination. Quickly noted down. Then one circuit we'll practice that will involve your both series and parallel combination. Here, Rava, in the chat column only. Whatever answer you're getting, no, are equivalent. Just send me here. If you have the full solution, you can send it on the Learnivio number. They'll forward me. I'll see your solution also. If you can, then that is also very good. Otherwise, you can send your R equivalent value. You can type here as well. Others also, not only Raba. See, Shaviz, if the values are not given, so you have to answer in terms of R only. R is given to you. That is the value which is provided. Yes, Rabba, it's not completed, the answer. You can type the answer also. See, we'll start with the class. Let me name the register. This is first, second, third, fourth. This is fifth. This is sixth. 6 registers we are having. Each value is capital R. So see, coming to these registers, you can easily notice here that branching is occurring, right? If branching is occurring, it means first and second, they are connected in parallel combination, right? If first and second are connected in parallel combination, it means 1 by R, 1, 2. This will be equal to 1 by R plus 1 by R. See, Shaviz, these are the values which you have. R1 value will be R and R2 value will also be R. So that becomes 2 by R. So R12 becomes R by 2, right? So we have simplified these two resistors, combined and made them as a single resistor. See, this is what we have now. Instead of first and second, which was separate two resistors, we have combined them and now we have obtained a single resistor whose value is R by 2, right? Individual values were what? R1 and R and R, right? Now we have R by 2. So R12 has been simplified. Now, R12 with R3. See, coming to R12 with R3. This you can see R12 and R3. They are connected. See, a single simple wire is connected. So they are connected in series combination. If they are connected in series combination, so R1, 2, 3 means R12 with this third resistor, their combination. You will just add it. That becomes R plus R by 2, which is 3R by 2. So instead of all these resistors, I will combine, instead of this whole, I will give one single resistor. That will be one single resistors in terms of these. So can I just place a single resistors in place of these? I will have this resistor, right? If I'll place this, I will have this type of resistor. Now coming to their connection. What type of connection do they have? You can see branching is occurring, wires are getting divided. It means potential is remaining same, current is getting divided. This is your parallel combination. So R123 means this 3R by 2. The three resistors have been combined and have been named as 3R by 2. R123 and this fourth resistor, they are in parallel combination. So if they are in parallel combination, 1 by R, 1, 2, 3, 4, right? This will be 1 by R plus, this will also be 1 by, it will be, means reciprocate it. So that becomes 2 by 3R. So denominator is 3R. This becomes 3 plus 2, that is 5. So R1, 2, 3, 4, this becomes 3R by 5. So I have obtained now 3R by 5. So 4 resistors we have solved. Initially, we just had one single R1. Then we combined it with second one and obtained R12. Then third was present. We combined it and obtained R123. Now we have combined it with the fourth one and we have obtained finally one resistor, which is 3R by 5. So what is the final shape of the circuit? Final shape is this. Now we have to find out equivalent resistance between all these three. So all these three, R1, 2, 3, 4, R5 and R6, all the three are connected in series. So your R equivalent, the final equivalent, this will be, add all these. How do we add in series? R plus 3R by 5 plus R. So this becomes 5 here, 5 here, 10 plus 3, 13 R. This is the 13 R. So R equivalent is 13 R by 5. This is your answer. See, Chavez, you have your answer also. 13 R by 5. Very good. All those who have not written, note it down. Now, one special case is there, which is known as infinite series, where infinite resistors will be given to you. So there is one method to solve it that we'll discuss after this. Note it down. Then infinite series we'll study.
Done, ma'am.
Done, class? See, if we have infinite series, in infinite series, no, you will notice that resistors are connected and the ends are infinity, means infinite numbers of resistors are connected. Now, how will you find the series and parallel combination, right? Because infinitely, you cannot keep on adding them either in series or in parallel. So the best method, if you get a question on infinite series, is to identify the repeating term. Like in this example, in this particular question, I'll discuss this question. So with the help of this question, try to find out how to solve these types of questions also. Suppose this is given. What is the repeating term? Can you notice? 1 ohm resistor, 2 ohm resistor, this plain line. 1 ohm resistor, 2 ohm resistor. 1 ohm resistor, 2 ohm resistor. If you can notice, this is the repeating term. This is the repeating term. This is the repeating term. Can you see these are the repeating term? So your first step is identify the repeating term in your entire circuit. Whichever terms are getting repeated, just identify them in your circuit. Fine. Identification of the repeating term. Let us assume that the answer to this entire infinite series is R. Suppose I have assumed that my answer is R. So I have to find out this R, right? This R is unknown to me. I have to find out this R. So equivalent resistance of the entire term is R. That is the first step. See, suppose I have solved it and my final answer is R. This is the final answer to this entire question. N number of resistors are added, repeating terms are infinite. My final answer that I am getting, the final answer, this is R, right? Now see, if infinite resistors have been combined and given the value as R, if I just add one single more repeating term, just one more set, will there be any change in your answer? If I have this as my repeating term, 1 ohm here, 2 ohm here, and this was the entire, suppose R, this was my answer, R equivalent I have got. If I connect them, means in this final R equivalent, if I add one more repeating term, just one more repeating term, will the answer vary? Will there be any variation in the answer? No.
Yes.
No, there won't be any variation. See, infinite series you are having, infinite. It's like you are having infinity. Infinity is a very huge number. And with this infinity number, you are adding +1. Just one single repeating term, where you had the entire circuits with you, and now you are just adding this one more, just this one little number. Will your answer be something else, or will your answer be still infinity? Your answer will still be infinity. What if I ask you, what is the value of infinity +1? Infinity +1, infinity +2, infinity plus even 1000. That will also be still infinity, right? So if I have infinite resistors with me, infinite, and I am adding just one more repeating term, there won't be change in my answer. That will still be R equivalent, will still be R, right? See here, R equivalent, look here. Step 2 is assumption. Assume that R equivalent is R. See, this R equivalent, this is the equivalent resistance of the entire repeating infinite series, this. And to this, I have just added one more repeating term, that 1 ohm and 2 ohm. Plus, the equivalent resistance of this entire circuit, this will also be R only, no? This will also be same. Because when you have added this repeated term, this isn't differing your answer. There isn't any variation produced, because this is such a small, one repeating term has been added to infinite repeating terms. If you are adding one repeating term to infinite repeating terms, your answer will still be the same in both the cases. It's like if you are having, let's say, 10,000. And I am just adding 1. So my answer is 10,000 Still, 10,001 is almost equal to 10,000 only, right? Or sometimes if you have like 1,000 plus 1, 10,000 plus 1, these are so small numbers. If I ask you to write 10,000 plus 1, you can answer it accurately, 10,001. But if you round it off and if you see the physical meaning, you'll still say it is almost 10,000. This is infinity. Infinite resistors are present and you're just adding one single term. So your answer won't differ so much. Your R equivalent will still be the equivalent resistance of the entire circuit. And what is the equivalent resistance of the entire circuit which we have assumed? That is R. Means even on addition of this repeating term, my equivalent resistance is still. Now what you can do, you can just solve this circuit. Our purpose is to find out this R, because that is the answer to our question. Why? Because R is the equivalent resistance of the infinite terms. You can notice here branching is occurring here. It means they are connected in parallel combination. Fine, they are connected in parallel combination and this resultant is in series with this. So add one more repetition term, R equivalent should remain the same. So here in this question, let us complete and find out the answer to this question. R and 2 ohm, they are connected in parallel. See, R and 2 ohm resistor, they are connected in parallel, right? So let's say 1 by R dash, I'm assuming. This is 1 by R plus 1 by 2, which is 2 plus R divided by 2R. So R dash is 2R by 2 plus R. And 1 ohm is still left. They are connected. They both are connected in parallel, R and 2. But this 1 ohm was also left. So that is in series with the resultant. Why? Look. See, if you replace R and 2 ohm resistor with this new resistance which we have obtained, this and this, they will be in series, right? They will be in series combination. So what is your R equivalent? R equivalent will be 2R divided by 2 plus R plus 1, R1 plus R2. So answer will become 2 plus R, 2R plus 2 plus R. So that becomes 3R plus 2. So your R equivalent is 3R plus 2 divided by 2 plus R. Class, what is this R equivalent? What did we discuss? This R equivalent is still R only. What have we assumed our R equivalent to be? We have assumed our R equivalent to be R. So it means this entire term, this is equal to 3R plus 2 by 2 plus R. This is equal to R only. This is what I was trying to tell you. See, I am repeating because understand this fact. See, their series combination R plus 2 parallel combination, their parallel combination plus 1 ohm resistor series combination is still the equivalent resistance which was assumed when the infinite resistors were present. Even if we have added one more term by ourselves just to get some other values, our answer will still be R. Is this part clear to you or to all of you or not? Yes or no? Faiza, Rabah, Rabia, Chavez. Is it clear till here? Why have we chosen this step? Because the rest of it is mathematics. After this, you will be able to solve it. This is clear or not? Should I repeat any doubts? You want me to repeat any part? Yes, Chavez. See, we are having infinite resistors. Fine. I am assuming that the equivalent resistance of these infinite resistors is R. So with these infinite resistors, I have just added one more repeating term. Now I have to find out this. That will still be equal to R ohm because infinite resistors were present and I just added one single repeating term. So my answer will still be the same as that was before, right? So I have found what is the equivalent resistance value. See, If you have infinite resistors, how will you solve it? You have no clue to solve it because infinite addition isn't possible. So what we do, we take the repeating term and take the equivalent resistance, which is still equal to equivalent resistance. Why? Infinite resistors are present. See here, infinite resistors are present. I have added one more repeating term. Their equivalent resistance is still equal to this only. There isn't change in my answer. So what did I do? Here in your actual main question, coming to your example back. This was the infinite series I had. I identified the repeating term and assumed that the equivalent resistance of this entire circuit is R. Now I have with this R, I just took one more repeating sum so that I can get some values and other circuits also. So I took their equivalent resistance is still also equal to R because with addition of this repeating term that didn't make any difference. So R and 2 were in parallel. So when they were in parallel, I got the answer as 2R divided by 2 plus R. And then their resultant, which was in series combination with this one. So when this was solved, R equivalent was obtained 3R plus 2 divided by 2 plus R. And this R equivalent is still equal to R only. Now is it clear? Chavez, any doubt? Still you can ask. Any particular point if you people are having any confusion? Rabia, is it clear? Rabia? And Rabah Parveen, is it clear to you? Rabah Parveen, it's clear to you?
Yes, ma'am.
Okay. Now see class. Now this part you all can solve. Till here you had to apply all the physics and all the concepts of current, electricity. This you can solve. See, 3R plus 2 is equal to cross multiply. That becomes 2R plus R square. Bring this term over here. R square minus R minus 2 is equal to 0. Let us split the middle term. So this becomes R square minus 2R plus R minus 2 is equal to 0. Take common R minus 2 here plus 1 here, R minus 2. So we have one bracket as R plus 1, another bracket as R minus 2 equal to 0. Equate them to 0. So R plus 1, this becomes minus 1 ohm and this becomes 2 ohm. Obviously, resistance can never be negative. So this isn't possible. So this is our final answer. Resistance is equal to 2. Which resistance is this? This is our equivalent which you assumed over here. And what was R? Infinite resistors answer means your final answer is this. This is the only way you can solve. Fine. Note down the infinite series, make it important. Same thing can occur in capacitors also. You can have the same concept in capacitors, but concept will remain the same where calculation formulas will be just different. Okay, noted from here. Any doubts still you are having, you can please text me in the chat column. I'll respond.
Done, ma'am.
Class completed till here, or is anyone still writing?
Done, ma'am.
Done, no? See, one just last topic for today, that is the case of Wheatstone bridge. I have discussed this with you in capacitors, but I wanted to discuss it again in resistors because this is asked. Wheatstone bridge. See class, regarding Wheatstone bridge, this we have seen, if the balancing condition is fulfilled, then no current passes through this because the potential difference becomes same across this and this point, right? 10 ohm resistor can be connected, or sometimes it can happen that instead of this, a galvanometer is also placed. Any type of question can be given. So what is the balancing condition exactly? We have discussed R1 by R2 is equal to R3 by R4. In capacitors, what was the condition? Balancing condition, it was C1 by C2 is equal to C3 by C4. In resistors, you have R1 by R2 plus is equal to R3 by R4. So this is balancing condition. Fine. So if this is the case, let us check whether this case isn't or not. This is R1, this is R2, this is R3, this is R4. Check this. So R1 by R2 means 10 by 20, right, is equal to R3 by R4, that is 20 by 40 or not. Yes, right. This is also half, this also becomes half, means the condition is balanced. If it is balanced, you can remove this. See, if I remove this, what will I get? I'll get this. Now it's easy to solve. Once you have that galvanometer or the straight wire removed with the resistor, with galvanometer, your conditions become easier to solve. Look at this. Now they are connected in series. They are connected in series. So R12 will become R1 plus R2, that is 10 plus 20, which is 30 ohms. This upper branch is having 30 ohms coming to the downwards branch. See, look at them. They are also connected in series. So R34 will be R3 plus R4, which is 20 plus 40, which is equal to 60. So upper branch has 30 ohm, lower branch has 60 ohm. Now can we combine the upper and lower branch? So will it still be series? It will now become parallel. You can notice there this connection is parallel. So if this connection is parallel, 1 by R equivalent will be 1 by 30 plus 1 by 60. 2 we can directly multiply. So that becomes 3 by 60. So R equivalent becomes 20. Just this one last case I want you all to write because this can come. And if it comes, no, your answers become very easy. Calculation part becomes very easy. All right, note it down from here and text me once you are done.